But I'm going to introduce Amy, who's going to lead us into the next round of H2O. H2O.
So this is more of a setup and a hands-on tutorial if you never ran H2O before. And what you should see on the screen is the VM loaded up, and you should have this open, hopefully by, if not by now, but by the R sessions, which will really be hands-on. So to start H2O, you simply click the green button on the page. It'll start H2O, and then we're going to run through a few of the data science workflow in the Web UI, and then afterwards, Patrick and Arno will introduce us to the R sessions. So here we have a loaded up H2O instance on our local host 54321. We're just going to command this. What you can do is go to our YouTube video, which is a short screencast that will show you the Web UI tutorial. If you don't have time currently to do it, you can always do it later. And there's a markdown doc that will give you the instructions as well as the click-through paths, so you can run the exact same demo that I'm about to run. Let's see. So let me just grab this. So this is a YouTube video. You can get that online later as well if you like. So first step is to basically import data and parse it into a format that H2O knows how to ingest and play with. So first you go to the Web UI, you go to data, and then you go to import data. There's also upload if you're importing the data remotely, but from your VM, you should be doing it locally. Once you capture the data path, you will be asked to basically confirm that this is the data you want to import. This is a preview of what your data would look like. And once you've confirmed that it was OK, you hit submit, it'll parse. And what you end up with is the data summary page or the inspect page. So let's see. So after you ingested the data, we do some exploratory analysis on the data set. So first, we do a short summary. And this is an airlines data set that's sitting on your VM. So it's should be accessible through data/H2O training/airlines all years 2k.csv. And all of that's available there. Once you have the data set, we're going to choose all the columns to view and then set the max number of columns at 1,000, the bins for the quantiles to 1,000, and then submit it. And what you get is a summary of each column. So for the integer columns, you'll see that we have everything from the quantiles, the min, the max, as well as some threshold levels here. Here we are. And for the categorical columns or the enum columns, we have a count of all the cardinalities as well as a count of each of the factor levels. So the next step would be basically to maybe split the frame into a test train split and then run a few models on it, a few classification models first just to predict the departure delays based on all the different variables and features in the data set. Just to make sure that you guys have something loaded at the moment, just to get an idea, can you show me a hand if you're following? No? OK. Oh, OK. Here we are, a few. So here, if you want to get an idea of what's in your KV store currently, you go to Data, View All, and then it will list out all the data frames as well as all the models, the model jobs that is currently in the session. So we're going to pick all years 2K, which was the airlines all years. And this is the model inspect page that we saw earlier. There are a few little links here. So there's random forest, big data random forest, GBM, GLM, deep learning, linear regression, k-means. So the models are linked on top. But on the bottom, you have things like summary. You can download the frame. This goes for frames that you create in H2O as well as frames that you import into H2O. You can export the file, split the frame. So split frame is basically what we're gonna do. So we're gonna split the airline's data set into 75-25 splits. And we're gonna shuffle the data set first, so we have a more random sample for the test string split. So what you end up with is 75% is in the first group, 25% in the second group. The number of rows, 32,000 versus about 11,000. So here we're gonna, we selected the testing set, or training set, and we're gonna create a generalized linear model. So all the models are, again, listed in the model section. So if you, on the top toolbar, you can hit model and then go to generalized linear model. So source here just means the source key. It's the data frame that you're gonna use to build the model. So it will autocomplete as you type it in. So here we have all years shuffle, part 1, part 2. So we're just gonna take the training set here, as well as the response variable is gonna be is departure delay, and we're gonna select all the, here's a little confusing, but the ignore columns, you're gonna pick all the columns that you're going to ignore. So highlighted already are features that have high NAs, which will affect the way GLM runs. So they're highlighted already to sort of urge you to ignore these columns because they have 37% NA values, or 36%, or even 99%. So, but if you look at the histograms that you got earlier in the summary page, or you have some domain knowledge on what to use, here we're just gonna ignore all the columns except for the day, the year, the month, day of the week, and the carrier that you're gonna use to fly, as well as the origin point, the destination point, and the distance that you're gonna travel to predict departure delays. So going down, we're gonna pick for family binomial. So we're doing a logistic regression using all the factor levels to return when we do variable importance. So we submit it, and we pull this. This loads pretty much instantaneously. So what we get on the model output page is the equation, as well as, since this is a standardized GLM, you get the coefficients as well as the normalized coefficients, which comes from the standardized GLM. And if you scroll down, right here, we have things like not just the deviance and the null deviance, degrees of freedom. We have an AUC, the AUC value, and the ROC curve, the receiver operator characteristic curve, which is calculated from all the confusion matrices at every given threshold level. So down here, you can select different threshold levels, and it'll give you a new confusion matrix every time, moving the points along the ROC curve. So you can choose your own sort of acceptance criteria. So going down here, this is this for GLM, this is just the absolute value of the coefficients, so the magnitude of the coefficients sorted. But for what you'll see later, GBM or random forest, we have not just the magnitude of the coefficients, but relative importance. So this gives you an idea of sort of features that you can select to rerun the model. So going on next, we're gonna do a GBM model. We're gonna do 2 GBM models, one with 5 trees and one with 50 trees. And at the end, we'll do some model comparisons, so you see the difference between a simpler model versus something a little more complex. And then compare it to something that ran really quickly and generally runs extremely quickly, GLM, versus something that might take a little more tuning, like deep learning, but could give a much better AUC value. So again, here we're picking the training set. We're setting the response variable to departure delays and selecting the same features for analysis. And basically, all the models follow the same UI, so response, ignore columns, and all the features underneath. There's explanations of it on our website, but let's see. for the most part, you can set them to default if you don't really understand what it is, or do a grid search, which I will show you later as well. So here we're running a 50-tree GBM model. It finished running, and you can see sort of the mean square error by trees going across there. Because this is, again, a classification model, you can go down and you'll see the ROC curve, confusion matrix, sort of same format. And below, this is the variable importance. So not just the coefficients, and they're not, expanded out. The categories aren't expanded out, so you actually get things like year comes out on top, and day of month, and all the way on the bottom, just month seems to be irrelevant here. Okay. So this is our HTML representation of the model in the Web UI. We're going to create another GBM model here. Again, this is going to model, GBM, and selecting all the features with only 5 trees. And we'll show you a model representation that in JSON as well as in Java. So there are different ways that you can take the output and visualize it. So it's not just the graphics that you see on a web page. It's basically whatever you want to make it out to be. So here we have the JSON output. And this is basically what we use for things like R and Excel, Tableau. We basically grab the JSON output, which is relatively small, and parse through the data, grabbing things like the coefficients and the model inputs, rather than the entire data set into other platforms that can't really handle big data. On the bottom here, the little Java model tab, you'll see it'll output the Java code that's basically your model. So you can be building models in R, but all the codes all the models are actually represented in Java. So you can go to the website, copy and paste this entire Java code and put it into any applications that you might want to use without having to translate the model that you built in R to something that you can run in Java. So I'm going to scroll down a little bit here. So you'll see one of the trees of the GBM model. So going down. Right here. So the first tree is just questions if certain criterion, yes, not, moving on to the next one. So it runs extremely quickly, and later on when I do the scoring process and the prediction process, all of that is basically going to use this in the back end to do sort of our nanosecond fast scoring engine. So next, I'm going to show you a model using deep learning. So deep learning with grid search. So if you don't know all the parameters going into something like deep learning, but you just want to try it out, but you don't know exactly which parameter to tune, you can maybe use multiple parameters, run many, many models, and see exactly which parameter which model coming out that gave the best result has a certain parameter, so you can go back and sort of inspect that and find out exactly why that fits your data set so well. So again, is step delay. We're going to choose ignore columns. So we're just, here we're not really changing any of the, here we are. So we're going to change in hidden. So the hidden layer sizes in deep learning, we're going to change it from just one interval from 200 to 200 to 10 and 10 by 20, 20, 20. So we give it 2 separate inputs, and it'll run basically both of them. So it'll run 2 deep learning model with the same parameters set at default for the rest of the models. Here. So it's just comma separated. And for a lot of the other parameters, you can do this and run basically multiple models. You can change another parameter to have 2 choices, and then you end up with 4 models, so things like that. So here we have the output, and this is the grid search process and output. So in the grid search process, you have multiple models being built. So you get a list of all the parameters as well as the models associated with it. And if you scroll all the way to the right here, you'll see that we have a prediction error rate as well as the models associated with it. And we sort it by the prediction error rate. So the first model coming on top is usually the one with the least error. So you can select that model. And so this is the deep learning output. Again, you can look through it. It's basically the status of the neuron layers. We have, again, this is a classification model. You can run a regression, or you just use autoencoders. But this is a classification model. So if you scroll down, you'll see the AUC value, sort of the standard statistics. Right. So next, we go to our multi-model scoring engine, which is in Score and then multi-model scoring. So this is our more graphical interface for prediction and model comparison. We're going to select our testing set now, so the smaller set that we've created from our split frame process. View all the models that are compatible. Select them, choose Score, and then choose the testing set here, and OK. So it's going to score. I created actually multiple models here. It scored about 11 models in 1 second. And this is the tabular form of viewing all the AUC curves side by side. But in the advanced tab, you have a table that you can sort by as well as overlaid AUC curves. So you can grab the most outermost curve and inspect on which model it actually is. And then here, I'm going to add a visualizations myself. So here, I'm going to choose to plot the amount of time it took to train the model versus the AUC value that I get in return. And so if you look at this, you see that some models are certainly outperforming the rest. So up here, this one has the best AUC value, but it took about 4,000 milliseconds to train versus the model that's maybe slightly worse off, 0.02 off, but it only took about half the time to train it. So this might not seem like a great difference right now because I'm working on a smaller data set, but if you have something big and vast, this might actually be important. Let's see. So here I have the first one I clicked was a deep learning model, and the second one I clicked is GBM. So GBM here actually took a little while longer than deep learning, the 53 GBM. And so getting about the same AUC value, so we can maybe look at the deep learning model instead and maybe predict specifically on this, grabbing back the prediction frame into our local disk, which we can actually munge and examine through. So here I'm going to create a frame with the predicted values. So we did the model comparison in the multi-model scoring engine, but we're going to actually create the frame so we can save it as a CSV. So here we're going to score, predict, and putting in the model that we want. I put in the GBM model, choosing the testing set, and calling it something like pred in our KV store. So we have a frame that's returned, and this is, again, at the inspect page, yes or no predictions, as well as the probabilities of yes, no. And then you can bring it into R and then set your own threshold levels and create your own prediction column. So just hit download as CSV, and it'll download as a CSV, or export it. So if we go back to our view all KV store and pick that same GBM model that we just used to score, we can actually, there's an option to save the model. So in case your instance ever shuts down, but you built a model that you really like and you don't want to have to recreate and wait for the model to build again, you can save the model and just reload it, which will take a fraction of the time. So here, this is going to save model. So you're just going to give it the path to where it's going to be saved, and see here. Submit. So the GBM file here is saved at data H2O training airline. So if next time I shut down this instance and I want to load it back again, that's where I would access the file. And in case you ever run into any error, null pointer exceptions, internal errors, This is where you would send us the logs, where we'll look through it and sort of detect whether it's a bug on our side or there's something different on your platform that maybe we can change or you can change to make H2O work. Basically, the log files are under admin, so there are a few capabilities like cloud status that will allow you to track the status of your cloud and download the logs. So here's inspect logs, and all you do is just download all the logs and just send it to us at support@hexdata.com. There we go. And so here, just shut it down, again, under admin and shut down. And that is our H2O tutorial. There's a short little snippet after that that will show you how to load the data back into H2O once you shut it down, if that's something you guys want to see. But is there any questions or yes? Right. Is there any way to manually what? Oh, okay. Oh, I see. Yeah, that's actually, you can do that as well. This will be more smooth in our H2O dev version of H2O, but currently, when you import the data set, it will auto-detect which type of column it should be. But then after you imported the data set, you can inspect the frame, and in our inspect page, let me grab that right here. So you see this over here. This is so the year got parsed as an integer, right? But you can change it into a factor column. So you can click as factor, and the whole column is treated as a factor now. So the same could be done for if it's imported as an enum because you have the numbers in quotes or something, you can maybe change it into integers. So that's possible too. Is there any other questions? Let's see. But let's see here. So hopefully you'll be able to run this yourself. All the information is on your USB drive, but I will assure in the next speaker.
So the idea is we want to get you guys hands-on as quickly as possible and come to some kind of checkpoint where we want to see how many of you have actually come to a point where you're able to install and run the product. So it's actually a super easy product to install. As some of you have done before, you can download the latest version from Hexdata or h2o.ai/downloads.